All right, today we're diving into a really cool electrical mystery, a hidden danger that affects everything from massive industrial plants right down to the solar panels you might have on your own roof. We're going to uncover why perfectly good equipment can sometimes fail in, well, pretty spectacular and dangerous ways. So let's just jump right in with a puzzle. Imagine you've got this brand new power cable. The box says it's rated to safely handle 100 amps of current. But when you run just 70 amps through it, which should be totally fine, it starts to get dangerously hot. So what's the deal here? Did you get a faulty cable? Are the numbers on the box just made up? Well, the wild part is the cable itself is probably totally fine. The problem, the hidden danger, is actually all around it. See, the real world isn't some perfect laboratory, and those real-world imperfections can literally steal a cable's strength. To really get this, we first need to understand one key term. That 100 amp rating, it has a name, ampacity. But here's the catch, and it's a big one. Ampacity is measured under ideal, totally standardized conditions. We're talking about a single cable hanging out in cool 30 degrees Celsius air with perfect ventilation. I mean, when was the last time you saw a cable existing in those perfect conditions? Yeah, pretty much never, right? So, if the official rating is for a perfect world, how do we actually stay safe in the real one? Well, that's where engineers use the super important safety principle called derating. It's basically how we adjust for reality. Derating is actually a pretty simple but totally vital safety calculation. What you do is you apply a correction factor, and it's always a number less than 1 to that ideal ampacity. And what you get is the true, safe capacity for that cable in its specific real-world spot. You can think of it as a reality check for electricity. You know what? This analogy makes it all click into place. The 100 amp rating is like a 70-mile-per-hour speed limit on a perfect sunny day. But what happens when a huge thunderstorm rolls in? You're not going to keep doing 70, are you? Of course not. Derating is just the process of figuring out that the new safe speed is, say, 45 miles per hour. Same road, different conditions, so you need a different limit. Okay, so what are these rainstorms for a cable? What are these real-world things that force us to derate? Let's meet the bad guys, what I like to call the heat culprits. These are the environmental factors that trap heat and stop a cable from cooling itself down. You know, the number one enemy for a power cable is heat it just can't shake off. And the first culprits are the ones you see all the time, a hot attic or a factory floor. That's high ambient temperature. Direct sun just baking a cable all day long? Check. And this one is huge, bundling a bunch of cables together. They're basically all huddling together and sharing their heat, which makes everything way, way hotter. And look, the difference is just night and day. On one side, you've got this perfect lab fantasy. And on the other, you've got the tough, gritty reality that cables face every single day. Hotter temps, crowded spaces, and that relentless sun. Oh, but it doesn't stop there. The way a cable is installed can be a major culprit too. If you run a cable through a sealed pipe or a conduit, you're trapping all that heat inside it with it. If you bury it in dry, sandy soil, that's like wrapping it in an insulating blanket. And this last one, it's one of the absolute worst offenders, leaving a long cable partially wound on its reel. Those layers just build up an insane amount of heat. It's a recipe for disaster. Okay. I know what you might be thinking, this sounds like it's getting complicated. But the good news is, the math behind this is super logical. It all boils down to a really simple safety equation. It's just 4 easy steps. Ready? 1. You grab the cable's official rating, its ampacity. 2. You look up the specific correction factors for each of your heat culprits. You know, one for the high temp, one for being in a bundle, and so on. 3. You just multiply all those little factors together. And finally, step 4, you take that total factor and multiply it by the cable's original rating. And boom, you've got your answer. All right, let's go back to our original mystery and solve it once and for all. We've got our 100 amp cable. We know it's in a hot place, so we'll apply a correction factor of 0.87. And it's all bundled up with other cables, so that's another factor of 0.70. So what's its real safe capacity now? The answer is just 60.9 amps. Wow, all of a sudden trying to push 70 amps through that cable seems like a really bad idea, right? It's almost 10 amps over its true limit in that environment. I mean, think about that for a second. Just two super common, everyday factors wiped out nearly 40% of that cable's rated strength. This is exactly why derating isn't some obscure engineering thing. It's literally a fundamental rule of electrical safety. So where does this all actually matter in the real world? The short answer? Pretty much everywhere electricity is used in tough conditions. Let's look at a few places you'll definitely recognize. Okay, picture a big factory. You look up and you see these huge trays crammed with hundreds of power cables, all running through a hot space near the ceiling. In that scenario, derating for both heat and grouping isn't just a good idea. It's absolutely critical for preventing fires. Let's bring it a little closer to home. How about the solar panels on a roof? Think about those cables connecting the panels on a blazing hot sunny day, sitting on a black roof. They are getting absolutely baked. You have to derate for that to have a safe and reliable system. And believe it or not, this is even happening inside the walls of your own house. You know the electrical wires that run through that thick pink insulation in your attic? Well, that insulation is doing its job. It's trapping heat, and that means those wires can't cool down, so their capacity has to be derated to prevent a hidden fire risk. And for a really heavy-duty example, check out mining sites. They've got this massive mobile equipment powered by these super long, thick cables. If an operator leaves that cable partially wound up on its reel while it's being used, my gosh, it basically turns into a giant, dangerous space heater. Derating in this case, it's literally a life or death calculation. So here's the big takeaway from all of this. A cable's rating isn't some unbreakable promise. It's really just a starting point. Its true strength is constantly being chipped away at by the world around it. Which leaves me with one last question for you to think about. Now that you know about derating, what invisible stresses are lurking on the cables all around you? You might be surprised by what you find.